The blade, this is the leaf. It includes the petiole as well as the blade. So this is the leaf. Petiole as well as the blade. Both parts are the leaf. Sometimes there's stipules. See these little leaf-like or scale-like structures at the base of the petiole? Those are stipules. Stipules are there to protect the young growing leaf. So stipules look like little leaf-like structures. And anybody know what this plant is, by the way? Geranium? Geranium? Which one? Yeah, okay. It's a geranium. There's other ones with stipules, but geranium, if you remember where that's at, over there, by the gym, in the flower box. That's where those are at. You've got stipules right there. Then we have the simple versus compound. This is a simple leaf. It's undivided. So we call that simple. You see here. This also has kind of undulant margins too. This one has a lot. Actually, geranium can be counted for like 5 things. It's got a simple leaf. It's got stipules. It's got undulate or wavy margins. And it's got a heart. If you turn this upside down, it's a heart-shaped leaf. That means cordate-shaped leaf. It's got pubescence. It's got a ton of trichomes on it. So this one could be counted on your scavenger hunt list for like 5 different things. So you want to get geranium, no matter what you do. So that's called a simple leaf there. Then we have compound leaves. Compound leaves are divided into leaflets. So I'll show you that next here in a second. But that means that the leaf is divided into different parts. So we call that compound leaf many. And there's different types of compound leaves. There is pinnate, which means feather-like. I'll show this on the next page for you. There's palmate, which means hand-shaped. Palmate-like. So palmately compound, pinnately compound. It doesn't even have bipinnately compound. Bi means twice pinnately compound. And so we have the heavenly bamboo over there that is bipinnately compound. It branches off this way, opposite of itself, and then within that branch, it branches off that way, and keeps going that way. So it does it twice. So that's bipinnate, double feather length. So compound, pinnate, bipinnate, and then palmate, palm hand thing that you got there. This is just to show you what we just saw. It's kind of low resolution. We'll just skip it. Here's some simple leaves. So we've got some simple leaf. Here's the petiole. There's the leaf. These are deeply incised. You could say, well, you'd probably say lobed for these. See how they're lobed? So if the edge is curving in and out like that, you'd call that lobed. So let me see if I think I put that on there for you to find. So I have undulate, which is a little more wavy. Then I have under lobe, which means the leaf edge is going in and out, kind of large indentations. What does it mean to have little teeth on the edges of the leaf, like right here? Serrated means, tooth-like, serrated, or saw-like. So you're going to be looking for a serrated edge of the leaf. You're going to be looking for this lobe. And you're going to be looking for undulate, which is kind of like this. The wavy. This is the compound leaves here. So this is, come back to the concept here. Here's a compound right here, compound palmate. See 1, 2, 3, 4, 5 leaflets. That's compound palmate. This right here is pinnately compound. So it's like a feather. The leaflets are going off on each side. See up here, this one? This is bipinnately compound. It comes up and goes off this way and that way, but then it also goes off this way and that way along each branch. So this is a palmately compound. This is pinnately compound, and that's bipinnately compound. This is regular pinnately compound. Too much? So there's a summary of that. Simple is just one leaf. Compound palmate, like a hand pinnate, bipinnate, or what they call doubly pinnate. What's to tell you there? That's mostly bottom. Get to the next ones here. And in terms of pinnation, these are the xylem and phloem that's running through the leaf. You're going to see parallel leaf pinnation, that's a monocot, grass. Palmate leaf, this is a palmate leaf simple. And this is typical eudicot and typical eudicot, both of these. These are netted venation. So if you see something like this, which looks like a hand, anybody remember where we had a big giant hand one? Yeah, over by the gym. There's some palmate leaf, simple palmate with netted venation. This is also netted as well, but this is palmate leaf netted. This is just regular pinnate netted or netted. There's shapes to leaves, and there's probably like 100 something different shapes to leaves. These are some basic types here. I'm going to ask you to find a lanceolate leaf, which looks like that, an oval-shaped leaf, which looks oval, and a heart-shaped leaf, which looks, you have to flip it upside down, it looks heart-shaped. So you're going to look for that. But geranium is typically the one where you would get that. As I talked about on the edges, there are ones with little teeth or serrations, there are ones that are undulate, and there's ones that are deep leaf in size, which are called lobe. If you ever see entire, that means it's smooth on the edge. The edge is smooth, they call that entire. They don't call it smooth. So entire means the edge is just smooth from one end to the other, from the tip down to the base of the blade. This is to show you, I don't think I'm going to have you look for any of these, but if you ever take plant taxonomy, then there's names for the base of every little leaf. And so there's a little more terminology. Here's the chordate base that I'm having you look for. But there's names to every single one of these. The botanists went out of control when it came to naming things. So they have names for the tips, they have names for the bases, they have names for the edges, they have names for everything. They even have names for the hairs on the leaves. So this is the pubescence. So if you see trichomes or hairs on a leaf, that's just called pubescence. So on here I say one leaf showing pubescence, one leaf that is glabrous. Glabrous means it's shiny. It has no hairs on it. It's smooth. So if you see a leaf like geranium, which has a lot of pubescence or trichomes on it or hairs, that's one you should get. When you look at them, some of you looked at these in the lab. When you look at them under the microscope, some of you saw some of these trichomes, some of this pubescence. You saw that they come in different shapes, and some of them are kind of spiny. Some of them, like you see here, are hair-like, and others are more for storage. So you see storage of chemistry in the tips, round tips like that. So they vary depending on, and they got names for them, just like everything. But you're just going to look for hairy or not hairy. Okay, so now going on to the leaf. You're going to look at 3 different types of leaves in lab, and this you can't see without the microscope. So those previous things we just did, that's kind of where you're focusing for your scavenger around. These next few slides just have to do with the leaf tissues that you see. And this is going back to kind of the photosynthesis days from the very start of class. This is all called that ground tissue in the leaf is called mesophyll. So see all this? That's palisade parenchyma. It usually occurs in two layers. One layer, 2 layers. And then down here you got spongy parenchyma. That's for storage. So these are for photosynthesis. The spongy parenchyma is for storage of water, nutrients. So that's all mesophyll, from there down to there. That's what we refer to that. So palisade parenchyma and spongy parenchyma makes up the majority of the typical leaf. The other thing in a leaf is, of course, the epidermis. That's the outer dermal tissue. The epidermis is on the top. and on the bottom. So they call that the upper and the lower epidermis. That's the dermal tissue system. And when you look in the epidermis, usually on a leaf like this is called a mesophyte. Mesophyte leaf is the standard leaf of the three types of leaves. So this is as boring as a leaf as you can get. So three leaf types. And the first one that you see there, that is, like I said, typical leaf. Meso means middle. And so you don't find these growing in the water, and you don't find these in the desert. So you find these in a typical, regular old, everyday, boring environment. You might think that. So middle plant, middle leaf is what you see here. The next two we do find in water, and we do find in the desert. So we call the ones in the water hydrophytes. These water plants. So those are in the water. And the third type, xerophyte, that means, xero means dry. That's a desert plant. Xerophytes. So like the oleander that you see here. So all three of these are very different. If you start to pick them down and look at them, you'll see some differences. And the main differences you see here is, see the mesophyte, the stomata? Typical plant, the stomata are going to be on the bottom. There's the guard cells, and there's an opening. So the stomata are on the bottom. You see the upper epidermis, the lower epidermis, there's nothing fancy there. If you come to here, the stomata are on the top of a water lily because there's no air down here in the water on the bottom of the leaf. So the stomata are on the top where the air is at, which is sitting on top of the water. And then the other thing you see here, which is different, is that you see these big giant intercellular spaces, which is full of air, so that the leaf will float. If you want to be a hydrophyte, you don't want to sink, because there's not as much light on the bottom as there is on top of the water. So those are the two main differences. The stomata are on top, and there's giant intercellular spaces here. The xerophyte, you'll see right away, has a multiple epidermis, upper, and a multiple lower epidermis. This thing is all about conserving water. So it's got extra thick layer of epidermis on the top and bottom. It's got extra wax or cuticle on the surface to protect it from, keep it from losing water. And then it, rather than put its stomata just sitting on the bottom, it puts them in these little crypts. So this is called a crypt. And inside of that crypt is the stomata with its guard cells. And it does that to prevent water loss. So everything about a xerophyte is to prevent water loss. From its stomata and crypts to its multi-layered to its cuticle. Waxy cuticle that seals the whole thing up. So those are the three types of leaves that you'll see in all of botany. Mesophyte, hydrophyte, and xerophytes. Maybe one more comment. It's still the same mesophyll. Here's the palisade parenchyma. Here's the spongy parenchyma. Here's the palisade parenchyma. Here's the spongy parenchyma. And the last few minutes I have here for you to show you the stomata on the leaves themselves. In a eudicot leaf, on the bottom, the stomata are randomly arranged. These are the guard cells, the lip-like structure of the guard cells. In a monocot, they're in rows. So everything in a monocot is always parallel and in rows. They're vascular tissue, but also they're stomata, occur in rows. This is a netted venation, showing you, here's again the petiole, that's the blade, the whole thing is the leaf. And this is showing you the xylem and phloem. That's all xylem and phloem. When you see those veins running through a leaf, that's all xylem and phloem that's packaged together, that's running through that leaf. You got more of it here a little less there, a little less there, and even a little less there. All the stuff in between is all parenchyma cells. It's a bunch of ground tissue that's making up the rest of that, where you don't see the lines. So when you look at lettuce there, that crunchy part, there, the crunchy part that runs in there makes it a little bit crunchy. All those veins that you see there, all that veins that you're seeing this way and that way, that's all xylem and phloem. The rest of it is really just a bunch of ground tissue, and what's making it green is a bunch of palisade parenchyma, which are full of chloroplasts, which are full of chlorophyll A, which is the green pigment that we see. So mostly what's in that leaf is mesophyll with ground tissue, and then you got a little bit of xylem and phloem scattered throughout there, which makes this venation that we see in the typical leaf. The last slide is on abscission. Leaves fall off, they become abscised, that's what that refers to. So the normal separation of the leaf from the stem. The term is called deciduous. So if you are a deciduous plant, that means that you will go through this process here called leaf abscission. And there's 2 layers that form. Like you see it says here, there's structural as well as chemical changes that take place that result in the formation of what they call an abscission zone. And that's it right here. So before you just drop your leaves, it would be wise for the plant to pull in all of its good stuff. So you put all that great material out into a leaf, and you have that leaf do work for you, photosynthesis. But before just cutting off the leaf and letting it fall on the ground there, plants will withdraw and pull back all of this stuff. Magnesium ions, sugars, amino acids, any lipids that are in there, all those pigments. First thing that comes back is the chlorophyll A, the chlorophyll B. Those are very large molecules. They cost a lot of energy to make those things. So right now what's happening around Salinas, if you look at the sweet gum trees, the liquid ambar trees, we have some on campus. What they're doing right now is they've already pulled all that chlorophyll A back in, and they're starting to now look yellow, they're starting to look red. Those yellows and reds, those are carotenoids that they're then going to try and pull back in to the plant. So really the first thing that comes is chlorophyll, and then that's when they start changing color, and then they'll pull back all that red and yellow, and eventually the leaf will be upsized, it'll fall off, and like you see here, it forms a sealant, which is a protective layer, and then it forms a separate layer, which is where it actually physically separates. Because you don't want, right here, you don't want viruses and bacteria and fungi infiltrating this plant. You want to seal that off with this protective layer. It usually creates a nice smooth surface like that. So that's all vascular tissue, and that's ground tissue, and then there's the dermal tissue on the outside. So this is what the deciduous trees are doing right now.